As the question says, a block of mass 0.2 kg is suspended from the ceiling by a light string. A second of mass 0.3 kg is suspended from the first block through another string. Find the tensions in the two strings. Now, let us draw the diagram for the given question. We have this as the ceiling. The first block is hanging with the light string and the second block being attached to the first block. Now the weight of this block is 0.2 kg and the lower block being 0.3 kg. Now mark these blocks as A and B and the strings being small a and small b. Let us also assume the tension T1 to be in the first string and T2 to be in the second string. Since the basic concept of solving any question lies in making the FPD of the question of the block, so let us draw the free body diagram for block A. Here is the block A, in which T1 is applied in the upward direction, T2 is applied in the downward direction, and moreover an mg force is applied in the downward direction. Since the system is in equilibrium, equating all the forces, we get T1 equals to T2 plus mg. Let us mark it as first equation. In the similar manner, we can make the free body diagram for block B, in which the T2 is acting in upward direction and an mg force is acting in downward direction. Again, balancing both the forces, we get T2 is equals to mg. Here, remember m is equals to 0.3, whereas above it was just 0.2. So we get T2 is equals to 0.3 into 10 because it has been given that G is equals to 10 meter per second square. So T2 is equals to 3 newtons. Putting back T2 into equation 1, we get T1 is equals to 3 plus 0.2 into 10 equals to 5 Newton. Now, in such type of questions, note that the strings have been given as light strings. Otherwise, the T2 in the equation 2 would not have been equal to T2 in equation 1. Here we have made the assumption that the strings are light. That's why we have found out the T2 in equation 2 and could put it in equation 1. So following this assumption, we have the answers as T1 and T2 equals to 5 and 3 newtons respectively.